This is Unit 7, AP Prep number 1. This is a slope field. And in the question it says start at 0, 1. So that's what I'm going to do. And I can draw the picture of the function and then match it to the one that matches the picture. So follow the flow, and get your picture and go, okay, which one matches that picture? And I said it's a little bit like bowling. You got to knock down the pins until one pin is left. So cosine is a wave. That's not a wave. Not a parabola, not an exponential, not a radical like this. And so the one that matches it is E. That's the picture. Number 2, another slope field. So for this one, I want to draw the picture of what it looks like. So I picked a point and drew it, and then recognize this is not a parabola, not an exponential, not a trigonometry, so the logarithm is the one that's left over that it can be. 3 uses a calculator. Now a puppy weighs 2 pounds at birth and 3.5 pounds later. The weight of the puppy during its first 6 months is increasing at a rate proportional to itself. Now, if I want to think of it as a differential equation, the rate it's increasing, then it's proportional to itself. That's what it looks like. And when I integrate this in terms of understanding, what I get is this, always. And I'm going to write it like this instead of pert, but that's what you get. And so you're going to see this often. So I'm not going to do the work to know that they are always connected. In the question, the original weight was 2 pounds when it was born. And then in 2 months later, it weighed 3.5 pounds. This is what you'd put in the calculator, and then you would solve it. And if you solved it with your calculator, you would get a rate of about 0.279. And now that you have that, you go back to this equation again. So now you have the full equation for the weight. And now it says, how about at 3 months old? So plug in 3 for t. And then use your calculator, and you get the answer 4.6. Done. Oop. Number 4. Bacteria in a certain culture increase at a rate proportional to itself. That's what it's saying. So if it's proportional to itself, then this is what it looks like. So if I write an equation, so that's the rate of bacteria increasing over time. That's what it's saying. Oops, it's really B. So that's the rate that it's increasing by. When I integrate it then, it's going to be pert, but I'm going to write it this way. And now you bring in the information. So it says it doubles. So when I divide by that original amount, double means 2, and it doubles in 3 hours. You can use your calculator. You're going to solve for k. So if you did it correctly, k is equal to for number 4, you don't have a calculator, so don't use your calculator. So you're going to solve for k a different way. So we need to write this as a logarithm. So the exponent equal to, the logarithm with a base of e is ln and 2, and then to get k by itself, it's ln 2 divided by 3. And then I come back again to this equation. Now I know the rate is ln 2 divided by 3. Now it says when it triples. So when it triples, it means it's 3. And then I need to know how long until it triples. So I'm solving for t. So I need to write it as a logarithm again. So we have ln 2 divided by 3. Ln 3. That's writing as a logarithm. To get t by itself, you divide. And that's your answer. And then when you look at which answer matches it, you can multiply it times the reciprocal, and you'd get this. So that matches with A. Number 5. During an optimal conditions, the rate of change of the population of a certain organism is proportional to itself. Wait, have you heard that before? So we're talking about population. So if I understand how it's changing, it's proportional to itself. So when I integrate, this is the equation that's going to come out of it. So I know the original population is 300. And then I know at time 24 hours, the population is 1,000. All right, again, you're not allowed to use your calculator, so we're going to solve for k. Divide by 300. Reduce it down. That's 10 over 3. You need to write this as a logarithm. So the exponent, the logarithm, and then 10 over 3. And then to get k by itself, divide by 24. Now we write the equation again, but now we know the rate. So there's our rate with t in the original population. Then it says, what time is the population 500? So you make it equal to 500, solve it, and then look for the answer. So to solve this, we're going to divide by 300. Reduce it down. Next, we're going to write it as a logarithm. So to write this as a logarithm, the exponent is ln 10 divided by 3 divided by 24. And then the base of e is ln, and it's 5/3. And then to get t by itself, there's a t here. To get t by itself, you divide, and that's it. So you just divide to get t by itself, and that answer matches with D. Six, I need a calculator. The quantity R in grams of a certain radioactive substance decreases according to that exponential model. So I have dr by dt equaling negative 0.05 R. This is proportional to itself, and that is K, the rate that you're looking at. So when I integrate this, it's going to be CE to the KT. That's what it's going to look like. And I already know some values to plug in. So the at time 0, the original population is 100. The rate is negative 0.05. That is the rate right there for K. And now I have an equation. I'm going to do the same thing for the second one. So the second substance is equal to negative 4. When I integrate this with respect to time, negative 4 is just negative 4t, but I do need a constant. And then at 0, the answer is 125. So that means when you plug in 0 for t, the answer needs to be 125. So C is 125. So it's negative 4t plus 125. Then the question says, at what time will they have equal quantities, right? Will they be equal to each other? So we just take the two equations, 100 e to the negative 0.05t, make it equal to negative 4t plus 125. So make them equal to each other. Use your calculator. One answer is going to be negative. You don't want that. The other one's positive, and it gives you this answer. And there you go. 7. A dose of 400 milligrams of a drug is administered to a patient. The amount of drug in milligrams in the person's bloodstream at time t is given by A at t. The rate at which the drug leaves the bloodstream can be modeled by this. And again, I want you to notice it is proportional to itself. So when I integrate this, that would be A at t, you get this PERT, or C times e to the kt. That shows up obviously quite a bit. And the original amount of drug in the system is 400. We don't know the rate. And it says, which one could be the equation? Well, we know this rate is negative. That's what I do know. And so when I turn the page, which one could be that equation where the rate k is negative? And if you turn the page, you would see that that answer matches with A. Number 8. Number 8 is a slope field. And it says, shown above is a slope field for which of the following differential equations would match that slope field. So I have 5 different ones I need to look at. The correct answer to all of this is this one. And you take one point at a time and then take that point and see if it works or doesn't work. Like, for instance, let's say I took the point up here. This is a point 3, 3. So if I plug in 3 for x and 3 for y, the answer should be positive. So like 3 times 3 is 9, take away 3. It's a positive answer. You could also focus in on slopes that are 0, if there's something that's undefined, and so on. So if you do it all the work, that's the one that actually matches, no matter what point you pick. All the rest, you could find a mistake and cross it out. Number 9. In number 9, you're given the diffie x divided by y, and you're trying to find the slope field that matches. So I think that like y can't be 0, so the slope would be undefined there, so it needs to be empty along the x-axis. That's why A is wrong. That's also why B is wrong. C is wrong because when you go x divided by y, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, they should all be the same slope of 1 all the way across. So it doesn't match. D also doesn't have that here. It should be 1, 1, 1, 1, 1, 1, like all the way here in the diagonal should be all 1 if it's x divided by y, so it's not right. So do you notice here that, look at this diagonal right there. So if I go y divided by x, the answer is 1, slope of 1 all the way to the corner. That is the correct answer. So the answer is E. Number 10. All right, in number 10, you have to be able to solve a diffie. So step 1 to solve a diffie is to separate the variables. So can you have all the x's on one side and all the y's on the other side? So I'm going to divide by y, subtract 2, and I'm going to multiply by dx. So that's what's called separating the variables. Next, we're going to integrate both sides. So the integration of a fraction, the derivative of y subtract 2 is 1, so it matches. So this is a logarithm. So it's ln y subtract 2. On the other side, the integration of x is x squared divided by 2. And the integration of negative 2 is negative 2x plus the constant. Next, I need to get y by itself. So I have to write this as an exponential. So what's inside the logarithm, y subtract 2, and then e to that exponent is right in it, exponentially. So it is a logarithm. You need to write it exponentially. Or given a point. Now, another way to write this to make it simpler is to take the constant and write it as e to the c, right? And use the exponent laws. So instead of adding, you could put them beside it. If they have the same base, they can multiply beside each other. So multiplying means you add the exponents, so they're equivalent. But this way, I can remove the absolute value bars, because it'd be plus or minus that constant, and then I can do a substitution. So I can say plus or minus e to the c, and I can rename that constant as c2. So we have, I'm going to rewrite it right now. So we have y subtract 2 is equal to a constant times e to the exponent x squared divided by 2 subtract 2x. There it is. So now I've written it in a lot simpler way. I'm now going to plug in to find what the constant is. So I'm going to plug in 4 for x and 5 for y. So if I plug in 5 for y, that's 3. If I plug in 4 for x, that's 4 squared. That's 16 divided by 2. That's 8. 2 times 4 is 8. That's 8. Take away 8. That's e to the 0, which is 1. So C2 is just, or that constant is equal to 3. So now I have everything I need. So what does y equal? So it's 3 times e to the exponent x squared divided by 2 minus 2x. And then to get y by itself, I had to add 2 to get y by itself. If you did the work correctly and go to the next page, you would see that that matches with the answer B. All right. Number 11. The general solution to that differential equation is already given. And it says, let y equal f of x. So they already solved it for you. And it gives you an initial condition. It says, which of the following expressions is the domain is valid? So I need to solve for c. It's solved for me. I just needed the last step. Do you notice the y coordinate is negative? So it's not plus or negative. It is negative to begin with. So it's y equals negative because the y coordinate is negative. And then I plug in the values. So y is negative root 2 and x is negative 2. And then I'm going to solve for c. So I can square both sides if you like. That's positive 2 is equal to 4 plus c. To get c by itself, you can see c is equal to negative 2. So it's y equals negative the square root of x squared minus 2. So already, when I look at the answer choices, B is wrong and D is wrong. What's the only difference between A and C is this domain part. And for what we're looking for the semicircle that is below, right, in terms of the axes. So the absolute value of x includes both the bottom and the top, but just x is less than negative 2. It includes just the lower part. So that's the correct domain restriction. So the answer number 11 is A. For number 12, you're given a diffeq, and you need to solve that differential equation. We separate the variables. So to do that, we multiply both sides by dx. And then I'm going to integrate. So the integration of dy is just y. The integration of ln 2 is just a number, whatever. A half, 2, 5, whatever it is. The integration of 1 over x is ln x. And then we just have ln 2 there in the denominator, whatever that is. And then plus c, and that's it. Done. A, things can be simple. Number 13. Let y equals f at x be a particular solution for that. And with an initial condition. Which of the following gives an expression of f at x and the domain for which the solution is valid? So this is a differential equation. We're going to separate the variables. So I'm going to multiply by dx and multiply by 2y plus 1. So we have the y is on one side and the x is on the other side. When I integrate this, I get y squared plus y. And on the other side, I get x, and then plus c, the constant. That was the easy part. Now comes the fun part. So to solve for y here, this is a quadratic equation. So I'm going to subtract x plus c, make it equal to 0, and I have to use the quadratic formula. I'm really sorry. So what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. I know. So I'm going to help you through it. So y is equal to negative b. So our b value here is 1. So negative 1 plus or minus the square root of b squared, which is 1, minus 4ac. Now, our c value is x plus c. That's a constant there. Think of that as a constant at the end, all divided by 2a. So already when I look at the answer choices, which is the only one that's even close to that? You can see it, right? You're given a value to plug in, 0, 0. So if y is 0 and x is 0, and you solve it, What are you left with? So if you plug in 0 for x, do that. The denominator doesn't matter. You're just looking at the numerator to make it equal to 0. So if I plug in 0 for x, that's what I'm left with. Add 1. Square both sides. And then I want you to notice as you solve this, c is equal to 0. So if I take the answer and solve it and put in 0 here, you're left with negative 4x. This is the answer right here. There's only one answer that matches it. I'm sorry you did the quadratic formula. Number 14, what is the general solution of that? In other words, can you solve a diffie-q? You should pause and really try. This is a foundational skill of calculus. Can you solve the diffie-q? Can you separate the variables? Can you integrate? All right, I'm going to do it too. So if you need my support, so be it. So we're going to integrate both sides. That's y cubed. That's x squared divided by 2 minus x plus c. To get y by itself, you cube root it, and that's it. Look at the answer choice. See, sometimes it's not that bad. And that matches with, well, not that one. This one, D. Cube root means the same as to the exponent 1/3. All right, that's 14. 15. In number 15, you're given a slope field, and you're given a point, negative 1, 2. And I want you to focus here. H at x is equal to that, and you're asked to find h prime at negative 1. So first of all, can you take the derivative using the product rule? That's the first, 3x, times the derivative of the second, plus the second, times the derivative of the first. And the derivative of 3x is 3. So there we go. Now I want to find the derivative at negative 1. So wherever there's an x, I'm going to put in negative 1. So 3 times negative 1 is negative 3. What's the derivative at negative 1? So if I go to the point negative 1, 2, right? So find negative 1 and 2. That's this one right here. What's the slope there? That's the derivative there. So down 2 and to the right 1. So it's negative 2. So the derivative at negative 1, you have to go to the point negative 1, 2 and find the slope there. F at negative 1, what's the value at negative 1 is 2. So F at negative 1 is 2. And then negative 3 times 2. Anyways, now it should get easier. 6 plus 6, so the answer is 12. 16. The rate of change of volume of water in a tank with respect to time is directly proportional to the square root of the volume. So proportional means you're multiplying. So the rate of change of the volume, that's dV by dt, is proportional, that's K, to the square root of the volume. So it's proportional to the square root of the volume. That answer is E. 17, the rate of change of the volume, that's dV by dt, with respect, is directly proportional to the square root of the volume. That's the same question. Why are we doing the same question again? Same one. We don't need the same one. 18. Let's try this one. The pressure P applied to a gas is increasing at a constant temperature. Then the volume of V of the gas will decrease. The rate of change of the volume of gas with respect to the pressure. That's dV by dP to begin with, right? So the rate of change of the volume with respect to the pressure is proportional, there's my K, to the reciprocal of the square of the pressure. So reciprocal of the square of the pressure, that's what it would look like. And because it's decreasing, K would be a negative rate. dv by dp, this one right here. Be careful, right? They're trying to trip you up here. And k is a negative constant because it's decreasing. Number 19, the weight of yeast is given by a differential equation, W, where WT is measured in grams and measured in hours. The weight of the yeast population increases with respect to time at a rate that is directly proportional to its own weight. So that's dW by dt, some k value directly related to its own weight. There it is. We know if we integrated that, it would be PERT, or CE to the KT. In the question, it says that time t equals 10 hours, which is not needed. The weight of yeast is 200 grams, so W is 200, and is increasing at a rate of 5. So if it's increasing at a rate of 5, dW by dt is 5. It's a rate increasing by that. So if I solve for k, divide by 200, I get 1 over 40. So now when I put it all together, dW by dt is equal to 1 over 40 times W. C is the answer. 20. 20 is a Diffie Q. Draw it. So y at 0, right here, is 0. So from 0, 0, draw and draw. And then think, what could that be the picture of? So could it be negative cosine? Could I start at the bottom of the wave and could it be continuing from there? Maybe. Definitely not an exponential. Definitely not sine. Definitely not tangent. Like the only one that it could be is negative cosine, where negative cosine starts at the bottom of the wave. You added 1, so that's where it starts. And then you continue the wave from there. So the answer number 20 is A. Number 21, another Diffie Q, but another slope field, I mean. So for 21, 0, 0 is right here. So it goes up like this, and it goes like that. Oops. So it has that picture to it. And then y at 0 equals 0. So a couple of quick ones we can cross out. So if I plug in 0 for x, the answer is 0. Well, 0 plus 1 is 1. Negative e to the 1 is not 0. If I plug in 0 for x, I get the answer negative 1. That's no good. If I plug in 0 for x, I get the answer 0. And here I get the answer 0. So which one of these could it be right? And the answer is here. Tangent is periodic. So that means that there'd be a pattern that repeats over and over again. And there would be undefined slopes to the right and left. So tangent has a bunch of slopes that are undefined, and that's not true to the right and left. So it is undefined at negative 1, and you can see at negative 1 it's undefined and blank there. 22, another slope field. So for this slope field, find the which one must be false. So F1 at negative 1 is concave down. So F1 at negative 1. Do you see where it is? Draw the picture around there. Is that concave down? Yes. The second one is negative 1 and positive 1. I'll find where that is. Negative 1 and positive 1. Draw it. Is that concave up? Yes. C, 0, 0. It says at 0, 0 it's concave up from negative 1 to positive 1. Well, it's concave up, and then it's concave down at 0, 0. So it's concave up, and then it's concave down. So it has two concavities. So C is wrong. D, is there a point of inflection at 0? And the answer is yes, because the concavity changes. Huh. I thought we were done with those kind of announcements now that what we have, but I guess I am wrong. 23. I was used to, like, sometimes I make these videos and there's constantly something in the background like that. And I thought, now there won't be anything like that in the background. I'm wrong. Okay, which of the following could be a slope field for this differential equation? So you look at each one and think, where is the mistake? and find the one that's left that has no mistake that would match it exactly. So try it, 23, and then I'll tell you the answer. So press pause, and then I'm going to tell you the correct answer. All right, so let me tell you the correct answer. So the correct answer is D. So did you find D to be the right? Everyone else has something that's wrong with it, but D is the one that matches. All right, 24. Shown above is a slope field. Which of the above is for the which of the following differential equation? So I want you again to press pause. I know if I expand this a little bit, it gets blurry. That's the problem, just so you know. And then find this. And I know it's blurry, so that's why I zoom in when I can. But unfortunately, when I zoom out a little bit, it doesn't have the ability to zoom back in. I try, but it doesn't want to. So only when I get super close. Anyways, which one could match? Again, we're looking for mistakes. We're looking for that. If you did it correctly, A is the correct one. At x equals 0, it's undefined, so it's empty along the y-axis. And then no matter which point you pick, you would find that it matches it exactly. All right, number 25. What's the solution to this one? So can you solve that diffie q? I'm going to start on the other page and solve it. So x times y squared. This is a big time skill again. So x times y squared. So what's the first step to solve this diffie q is to separate the variables. So we're going to divide by y squared and multiply by x. I'm going to write this as negative 2. So this is really y to the negative 2. So we're going to add 1 to the exponent and divide. And then again, add 1 to the exponent and divide. We're given a point. What's the point we're given again? Is 2, 1. So we're going to have to use that point, 2, 1. Anyway, I still want to get y by itself. Now, if I plug in the point, right, I could do it right now and solve for c. So if I plug in 1 for y and 2 for x, I can solve for c, and then I'll solve for y. So 1 to any exponent is 1, but it's negative in front, so it's negative 1. 4 divided by 2, subtract, and c is equal to negative 3. So that's good to know. So now we can come back to this step here and put in negative 3 for c. So we have negative, and it's 1 over y, is equal to x squared plus 2, subtract 3. So that's what we have. Remember, y to the negative 1 is 1 over y. I'm going to get common denominators. That's common denominator. I'm going to write it as one fraction. So then I'm going to do the reciprocal to both sides. And then the last thing I need to do is divide by negative 1 to get y by itself. So I can either divide the numerator or the denominator. So if I divide the denominator, I get negative x squared plus 6. And that matches with D. All right, number 26. Which of the following is the solution to this? Again, we're going to solve this diffie q. So we're going to multiply by dx. Integrate it. So that's y. 2 sine x becomes, the integration of sine is negative cosine, so it's negative 2 cosine plus c. We're given a point, which is pi 1, so y is 1 and cosine is pi. The value of cosine at pi is negative 1 on the unit circle. So negative 2 times negative 1 is 2, subtract 2, so c is equal to negative 1. So put it all together. Y is equal to negative 2 cosine x, subtract 1, and you have it. So that matches with E. 27. Which of the following is a solution to this? So again, can you solve a differential equation? So let's start with this part first. Separate the variables. So here I need to know exponent rules. So I'm going to go e to the y times e to the x so I can separate them. So when I divide by e to the y and multiply by dx, this is what I get. Now this is the same as e to the negative y. All right, now I can integrate this. So the hook is -1, so I need a negative in front. So when I integrate it, it just stays the same with the negative. That's the rule for e. And then to get y by itself, I need to write this as a logarithm. So the exponent is -y. Here, actually, I should multiply everything by negative first. So e to the negative y is equal to negative e to the x, if you like, minus c. So then to write it as a logarithm, oh, here, you know what? Let's just do this. At this step right here, let's solve for the constant. So it's y at 0. So x is 0. So e to the 0 is 1. So on one side, I have 1 plus c. And then if I plug in ln 4, it's actually a negative ln 4. So a negative times a negative is positive ln 4. Now, e and ln cross out. That just leaves me with -4. And then subtract 1, and c is equal to -5. So I think that's helpful. Now the equation we're going to go back to. So we have this equation. Negative e to the negative y is equal to e to the x, subtract 5. Now I know what c is. Now I'm going to do the work to get y by itself. So I'm going to divide everything by -1. So that makes it negative e to the x plus 5. Write this as a logarithm. So it's negative y is equal to ln, and it's negative e to the x plus 5. And then divide by -1, so it's negative ln, negative e to the x plus 5. I know, but you know what? Turn the page and you'll find it. And that matches with C. All right, 28. The population P of a city grows, oh, we've seen this, haven't we? Proportional to itself, a constant times P. We've seen this. So if I integrate this, that's what it's going to look like. It says if the population doubles every 12 years. So if I divide by C, it doubles every 12 years. So use your calculator and solve for K. If you did it right, you get 0.058. The question is, what's the value of K? I just found it. 0.058, and it's over. 29. Which of the following is a solution to this differential equation? So again, I need to separate the variables. So I'm just going to divide by y, just to get y over here by itself, and then multiply by dx. I'm going to integrate both sides. The integration of 1 over y is ln y. The derivative of x squared plus 1 is 2x. This is a logarithm. And the hook is perfect. So it's just ln x squared plus 1. And then it says the point is 0, 1. So if I plug in 0 for x, ln 1 is 0. If I plug in 1 for y, ln 1 is 0. That's one of the properties of logarithm. 0, 0. C is 0. So all I'm left with is ln y is equal to ln x squared plus 1. They both have a logarithm. They can undo each other. And that's it. You're left with y equals x squared plus 1 is your answer. And that matches with B. All right, 2 left. Here we go. Number 30. If f at x is a solution to that differential equation with the initial condition 0, 2, which of the following is true? So if I integrate this, it's going to be trouble because I don't have any rule for this. See, the hook for x squared would be 2x. I don't have like terms to be able to undo it or have a rule for e to the x squared. So I have nothing there. Instead, to understand f at x, you're given an initial value of 2, and then you do integrate from that x value, which is 0, to any x value you want using the derivative. And you would change the variable and do that substitution. That is another way, right? A little bit challenging. Another way to understand what a function is. This is called a starting value question. And so that matches with D. All right, where did it? Right here it is. Done. 31. All right. Can you solve this differential equation? So really, just integrate it. Understand, let's do it this way, that this is cosine x squared. So the derivative of cosine is negative sine. So when I integrate this, I need a negative in front. So it's just a negative in front, and then I add 1 to the exponent and divide by that exponent. So it does need to be negative because the hook needs to be negative, but sine is already there. And then you add 1 to the exponent and divide. Find the constant. So we're given a point, which is x equals pi over 2, and y is 0. So when I do that, the value of cosine at pi over 2 is at the top of the unit circle. It's 0. That's the x coordinate up there. It's 0. So c is 0. So if I put this equation together, I get this. Because c is 0. And then it says evaluate it when x is 0. So now that you have the equation, plug in 0 for x. The value of cosine at 0 is 1. So it's negative 1 over 3. It's negative a third. Done. All right, we got 1 left. 2 left. We got this. 32. The derivative is 2 over x. I got my notes here. I got mixed up here. So the derivative there it is. All right. So the derivative is 2 over x. And f at root e is equal to 5. What's f at e? This is a beginning value problem. We start with the value of 5. And we're going to integrate from root e to what I'm looking for, which is e. And I'm going to use the derivative, which is 2 over x. So there's the setup. Starting value. And we start at root e. And I go all the way to e. And I integrate the derivative. That tells me the increase or decrease from 5. So 2 over x to begin with is just 2 ln x when you integrate it. And it goes from root e to e. And then I plug in e to begin with. Well, ln e is 1. So that's just 2. Subtract. Now this one takes a little more thinking. If I plug in root x, root e, you get 2 ln root e. Well, that's the same as 2 ln e to the 1/2. So a property is the 1/2 can be multiplied in front. So 1/2 times 2, that's just 1 ln e, which is 1. So we got 5 plus 2, take away 1. What is that? 6. Oh my. Right? Nice and simple. This one's the last one. Number 33. A curve has a slope 2x plus 3. So that means dy by dx is 2x plus 3. That's what the word slope means. The derivative. Integrate it. So if I integrate this, y is equal to x squared plus 3x plus c. They give you a point 1, 2. So the y value is 2, the x value is 1, and then you solve it. So that's 1 plus 3, take away 4. So c is equal to negative 2. And then if you put it all together, it's y equals x squared plus 3x minus 2. And that's it. The answer to that, if you look and turn the page, is D. You just did your work. Good job reviewing unit number 7. I'm so proud of you for doing your work and working hard. Mr. G Math over and out.